3.5 is transformations. Every year I'm going to grab that clip from A Bug's Life where they're saying transformation. Nah, it's not that important. No. No, it's not. Every function transforms with this same rule. The ones on the lab you just did were all parabolas. They were all quadratics. But it doesn't matter what your function is. They are all going to follow the same basic rule for transformations. What does the word transformation mean? Change. Change in shape, change in size, change in position of some shape. Okay? So, for any function f of x, if you have some number on the outside and a number on the inside here and another number out here, each one of those numbers does a different thing. Now this looks a little weird because I've actually got f of x in there instead of like what you did today. So what you worked on today, for example, with quadratics, y equals a times x minus h squared plus k. So since it's a quadratic function, it's going to have the h inside parentheses with a square, right? What if it was some other function? Name another function besides quadratics that we learned about. Oh, circle's not a function. Something else. Josh, what's your question?
So, like, the standard form is y equals mx plus b. Like, isn't m just equal to a? Would you write m instead, or are you always going to put a? And wouldn't a be equal to b?
Yeah.
All right. Did you just pick those variables, or one of the sections?
Mx plus b is widely accepted.
But, like,
But based on these rules, you could think of them as a and k. All right. So somebody mentioned a square root function. We could do square root. A square root of x minus h plus k. Okay. Y equals a absolute value x minus h plus k. You don't have to write all these down. But in general, that's the basic rule. Do you see how it applies to these different functions? Okay. So later in this class, we will be doing exponential functions. They're a little bit weird because you have like a base to a power. So like a to the x minus h power plus k also applies. Okay, but I don't think there's any of those on today's assignment. Okay, let's talk about what each thing does. So, now I can't see what I wrote a few minutes ago, so let's just write it down again. What does the a value do? A is like the slope, right? Instead of calling it slope in general for these other shapes, we call it the vertical stretch. Because what it actually does is take all of the points and where they normally are and multiply them by that number. So if there was a 2 there, it would take all of the y values and multiply them by 2 from where they would normally be, which has the effect of stretching the graph, so it makes it taller and makes it appear to be skinnier. It's not really skinnier, it just appears to be because everything's stretched upward. Okay? What if a is negative? It's upside down, so upside down, or what we would officially say is reflected over the x-axis. Okay? Now, here is one thing I didn't put on your lab that you need to know. If the x is negative, any ideas on what that does? It, instead of turning it upside down, it's going to reflect it over the y-axis. Okay, so that wasn't on your little self-starter assignment, but that's something we will talk about. Okay, h. What does h do? Moves right or left, but what's weird about that one? So it kind of goes the opposite direction of what you think it's going to go. Okay, and then what is k? What does k do? Okay, it moves the graph up or down. Okay, let's look at an example. If I give you y equals the square root of x minus 2, how would you graph that? First of all, what do you have to know from section 3.4? You have to start by knowing what these graphs look like. So you have to know those. If you don't yet, please learn them. So it's something to that effect, correct? So the negative 2 inside the square root, is that going to move it left or right, or up and down? It's going to move it horizontally, and because it moves horizontally, see how the 2 is inside the equation? So that moves it horizontally, and it goes the opposite direction, so it's going to move to the right too. So usually you take like an important point of the graph, like a square root graph actually has a starting point, or if you have a parabola, it has a vertex that's easy to move around. Or if you have an absolute value, it also has a vertex. Or if you have an x cubed, it kind of has that little middle point where it goes both directions from there, right? Anyway, so take whatever point it is and then do this to it. So the minus 2 means it goes to the right too. So there's an approximate graph. I don't care about these being absolutely perfect. But let's look at a different problem. What if we do the square root of x plus 3. How are these different other than one's a 2 and one's a 3? What else is different? This was inside the square root. It's the horizontal shift. This one is outside of the square root, so it's a vertical shift. What if I had written it like this instead? Does that mean the same thing? Yes, it still means the same thing. There's this little property in math called the commutative property, that 3 plus 4 is the same thing as 4 plus 3. It doesn't matter what order they're in, right? So it doesn't matter if the 3 is first, it still does the exact same thing. It's just going to move the entire graph up 3. Okay, let's look at a different one. Let's look at y equals, ooh, this one's going to be a little weird, and on this one you need to be careful. Actually, let's do a negative. Okay, so what, do you remember what I said this number does? It's sort of like the slope. Not exactly, but sort of.
It like
stretches it vertically. Okay, so what does the negative do? It's going to flip everything upside down, because just like the 2 is going to double all the y values, the negative is going to make all the y values negative, right? So we would normally have a graph that goes through the point 0, 0, and the point 1, 1, and the point 4, 2. Why would those be the points that that graph normally goes through? Where did I get those points from? Did I just make them up? Because they're square roots, right? So if I do the square root of 0, I get 0. So this is just your y equals square root of x. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Right? So take those answers and take the y value, take this answer, the y value, and multiply by a negative 2. So what's 0 times a negative 2? 0. What's 1 times a negative 2? Negative 2. What's 2 times a negative 2? Negative 4. So what has it done to our function that originally looked like this? Or like this? What's happened to it? The negative has flipped it upside down. Good. And what has the 2 done? Stretched it so that those y values are twice as big as they were originally. I feel like I'm losing you. Is that enough examples? Is that what you're telling me? Let's do one more. If I have y equals, actually I lied, we're going to do 2 more. If I have y equals the square root of x, negative x plus 5. What do you think that means? These are a little tricky. I'm not expecting you to know exactly what that means. That's why I'm showing it to you. Tyler, not right now, please. That's where it flips over the y-axis, but the thing that people do wrong sometimes is that they think, okay, that goes over the y-axis, and then what does the 5 do? Goes to the left 5, you would think, right? Yeah. No, watch what you have to actually do to it. You have to actually take that negative out and put it in the front of that inside section. It's like you have to factor out that negative. And so this one causes it to reflect over the y-axis. But this one does what to it? Actually moves it to the right 5. So it should look 1, 2, 3, 4, 5. It should look like that. Now, for some reason, I'm questioning myself. So guess what I'm going to do? I'm going to try it and just double check it. Oh no, guess what? Oh, never mind. You know what? I did it wrong. I put a minus in there. Wasn't my original problem a plus? Okay. I'm like confused going, I swear it goes the other way. I did it right. I just typed it in wrong. Okay. Okay, so that's why if you put something like that in your calculator and you get it like this and you think, wait, that went right 5, it was supposed to go left 5, that's why. Okay,